Bismillahirrahmanirrahim. Greetings. The topic and the discussion of this lecture is going to be about a least common multiple of two or more natural numbers. So we are going to discuss what they mean and seek for a possible way to find them. And also I mentioned a few words about their benefit and their application. Okay, then that's all. Let's get started, shall we? Now, suppose we want to find the least common multiple of, let's say, 2, 3, and 8. Now, 6 is a multiple of 2 and 3, but is not a multiple of 8. So 6 is out. 8 is a multiple of 2, but is not a multiple of what? A multiple of 3. So 8 is out. You're doing trial and error. 12 is a multiple of 2. 6 times 2 is 12. Is a multiple of 3. 4 times 3 is what? Is 12. But is not a multiple of 8. So 12 is out. Prime numbers like 11, 13, I don't have to mention because they are only multiple of 1. They are not multiple of any other numbers. If they are done, we don't call them prime. So next one to try is 14, will fail. Then next we go to 16 will fail, 18 will fail, 20 will fail, and 22 will fail. And then we'll go to 24. 24 is a multiple of 2. 12 times 2 is 24. 24 is a multiple of 3. 8 times 3 is 24. 24 is a multiple of 8. 3 times 8 is 24. Here you are. 24 is a multiple of all three of them, and we did not find any number less than that to be multiple of 2, 3, and 8. So 24 is the smallest natural number, which is a multiple of 2, 3, and 8. Now, then we notice that every multiple of 24 will also be a multiple of 2, 3, and 8, which is a common multiple of them. Like, for example, twice 24, or which is 48. Let's say 3 times 24, which is 72. So we can have a long list of multiples of 24, and all of them are multiples of 2, 3, and 8. But in that collection of sets, 24 is the smallest one. As a matter of fact, all the multiples of 24 is a subset of natural numbers. And according to well-ordering principle, every subset of natural number contains the least element. And the least element of all the multiples of 24 is 24. So the principle of well-ordering principle is also applied for that. Now, the question is, what about if the numbers are large? Like 5,777, and next one is 12,029, or something like that. How can we find the least common multiple of them? And if the numbers are in their millions, and we want to do by trial and error, pen and paper, it may take us not months, but years. It's not practical. So we have to find and look for a systematic way to somehow find the least common multiple of 2 or more numbers. Common sense, isn't it? Now, one of the advice that I have for my students, and I have also mentioned in my almost many of my lectures, is that whenever you encounter with a problem that is difficult, or maybe you haven't the faintest idea how to start, try to seek for a similar and familiar and easy example of your own, and then use the solution of that as a kind of prototype to guide you to solve the hard problem. We have used this strategy in the past for many other problem solving, and it has been very effective, so we want to apply it in this lecture as well. So I have on the board a few examples, and I'm going to go over that. So with your permission, I'm going to zoom it so that I can go on the board for you. Okay, now let me stay out of your way. Now, we want to find a list common of multiple of what? Of 6 and 9. We know what that is. 6 and 9 is 18. We already know the answer. That's why you said the strategy. We look for a simple example to help us to what? To solve hard problem. So here, notice that I write the prime product of 6 and 9, and I wrote them in exponential form. And I have already mentioned this is the 4th lecture in that mini-series. In the last 3 lectures, I have gone over how to decompose a composite number into product of its prime. So we know how to do that, and I didn't go over to do it one more time. It should be really, if you have watched those videos, those lectures, this should be very simple. Okay, then, now I go for another simple example and see what I can come up with. Suppose that I have been given, they want me to find the least common multiple of 14 and 8. So by trial and error, I found out it is 56. Do you follow me so far? By trial and error, I found 56. Now I go and find the prime decomposition of 14, the prime composition of 8, and prime composition of 56, and I see if there is any kind of relation, if it's going to give me some kind of hint so that I can apply it for the harder problem, as I did that here. So I come back to this in a minute. Now when I do that, look what happens. When I do that, 14, the prime product of that is 2 times 7. 8, the prime product of that is 2 times 2 times 2. Writing in exponential form is 2 to the 3. Now, then I go and use prime decomposition of 56, and I found out to be 2 to the 3 times 7. I wrote it in exponential form. Now I look at 2 to the 3, 7, and these 2 to see if I see any kind of hint, any kind of relation. I notice that this has 2, so 2 is there. This has 7, 7 is there. This has 2, then I look, this is the power of this 2 is 1, the power of this 2 is 3. So the larger one wins. So I write the 2 factors, and I write the larger of the 2 exponents. So for instance, if there was another prime number, let's say 11, then 11 should also appear here. If that was another prime here, for example, let's say 13, then 13 should also appear here. Do you follow me? Now look at this one, very similar to the first one. 2 and 3, they are factors of that, 2 and 3 are there, you see that? And then this one is 3 only, 3 is already there, I have written. Then I look for the power. The power of this 3 is 2, the power of this one is 1, the bigger one wins. So 2 times 3 squared will be my least common multiple of these 2. So from this observation, I come back to kind of generalize it in a sense and systematically do that. Now let's see, I have another example here to make. Suppose that the two numbers that I want to find the least common multiple of them, one of them is 360 and the other one is 864. I want to see what the least common multiple of that will be. So I go ahead and use Alice's vertical decomposition of composite number that we covered in the previous 3 lectures, and I have already done that, so I don't go through that, and I urge you to do that. And if you have watched those videos, this should be really simple for you. So I decomposed 360 into product of its prime, and I wrote them in exponential form. So as you can see, it's 2 to the 3 times 3 squared times 5. That is the prime factorization of that. And I did the same thing with 864 using the vertical line technique, and I end up with 2 to the 5 in exponential form times 3 to the 3. Now, what will be the least common multiple of these two numbers? 2 should be there, 3 should be there, 5 should be there, and there is no other term. So I write all of them without the exponent. You follow me? I write all of them without the without exponent. Now look what happened. Then I look for the larger of the 2 to the 5 and 2 to the 3. 2 to the 3. So 5 wins. I put question mark with a pencil. I hope that it is visible to you. So 5 will win. So I write 5 here. After I wrote all the factors that they have. If there was a 7 here, I would have put it. If there was 13 here, I would have put it. But they didn't have. I wrote all of them without the exponent. Now I go for 3 and 3 to the 3 and 3 to the 2. So 3 wins. The larger one wins. And then I go to 5. Is 5 to the 1. There is a 5 here, as a matter of fact. That 5 is 5 to the 0. Because any non-zero number to the power of 0 is 1. I didn't have to bother to write it. So 5 to the 1, 5 to the 0, 1 is the larger, that wins. Here it is. This number will be the least common multiple of 360 and 864. Do you follow me? So let me now zoom this one back. Okay, now the least common multiple and the greatest common divisor, they have quite many applications, in fact, in mathematics. And one of them for elementary, developmental mathematics level is doing arithmetic with fractions. I've already mentioned about, like when we want to find 2 or more fractions to add, they call it least common denominator. Common denominator. The common denominator end up to be least common multiple of all the denominators. That's one application. And there are other applications that, a little going to go upper level courses. I'm not going to discuss it. And also I have a kind of, I don't know if I call it homework, but a very simple example for you, and I want you to do it, is very elementary arithmetic. Find least common multiple and greater common divisor of 2 numbers of your own selection. Alright? Once you find the least common multiple of them and greatest common divisor of them, multiply them together and see what you will get. That could be maybe considered another kind of application of them. Okay then, I thank you for watching, and for the next lecture I plan, inshallah, to go to Euclidean algorithm and find the greatest common divisor that way, and then go through the deductive proof of that. Okay, then I thank you. I hope all these video lectures are beneficial to you. And if you have any special topic freshman, sophomore mathematics curriculum level, you are welcome to mention it in the comment section below, and I will be happy to upload a lecture about that for you. Okay, then for the second time, I thank you for watching and have a pleasant and blessing day. So long.